Good evening. Welcome to Chicago Students Dominate Math. My name is Mr. Hendricks. I'm going to be your math tutor for this evening. This is a live call-in interactive show brought to you through the facilities of CAN TV. I want you to call the number 312-738-1060 to ask all of your math questions. I'll do the best that I can to answer whatever questions you have. I have so much to talk about, so let's just jump into it. We are not going to waste any time at all. All right, so today's topic has to do with vectors, and we're going to talk about matrices a little bit and how the two topics are somewhat interrelated. All right, so first, you're looking at this three-dimensional prism shape, and the way, using geometry, you would possibly want to find the space inside or the volume of this would be length times width times height. The area of the base, or the length times the width. This here, this is 3, and this here is 4. So the area of the base is 12, and then the height would be 2, and you'd end up with a volume of 24 units cubed, 24 cubic units. That's a very, very common geometry type problem, but one of the things I want to do is introduce another technique of finding a volume using vectors and using matrices. All right, so the way you could find the same volume is using a formula, more of a linear algebra technique. You'd use a formula, volume is equal to the dot product of vector A times the cross product of vector B and C. All right, so let's call this vector vector A. That's why I've got this arrow here. Let's call this vector vector B, and let's call this vector let's call this sorry about that. Let's call this vector B. Let's call vector B this vector right here. And this is an x-axis, so this vector would be called this vector is going 3 in the x direction. This vector is going 0 in the y. This is my y-axis, going 0 in the y direction, and this vector here is going 0 upwards, 0 in the z direction. So we're calling that vector B, and we're calling this vector C. Vector C, this vector here is lateral, so it's going 0 in the x, it's going 4 on the y-axis, and it's not going up or down, so it's going 0 in the z direction. All right, and this we're calling vector A. So vector A, this vector is 0 in the x, 0 in the y, and 2 in the z. All right. So the way you'd find the volume of this prism is to take B cross the cross product of vector B and C. All right, so the way you take a cross product is you need to establish a matrix. That's one way. All right, so let's put I, J, K, and we want the cross product of B and C. All right, so my vector B is 3, 0, 0, and my vector C is 0, 4, 0. All right, so one way to take a cross product is to take this position here, I, and find the determinant of this submatrix. All right, and hopefully you can see that the determinant, if you cross out this I, cross out this row here where I is located, and you find the determinant of this submatrix, hopefully you can see that this would be 0 minus 0, which is just 0. All right? and then minus by rule j, and then you do the same thing. You cross out this row, you cross out that row, and you'd find the determinant of the submatrix that's left over. If you cross out this row and you cross out this row, hopefully you see that you end up with 3 times 0 minus 0 times 0, that's 0, and then plus k times the, if you cross out k and cross out the row where k is located, hopefully you can see that the determinant of the submatrix will be 12. 12 minus 0. All right, 12 minus 0. All right, so you end up with 0 minus 0 plus 12k. Right? So the cross product here is 12 in the k direction. 12 in the k direction. 12 in the z direction. All right. So now what you need to do is find the dot product of vector A and the cross product. So the way you would do that is vector A, we said, was 0. Another way you could write the vector 0, 0, 2 is you could write that 0 in the I direction, plus 0 in the j direction, plus 2 in the k. That's another way you could, this vector can be rewritten like that one, and you are taking that vector and you're dotting it with 0 in the I direction, plus 0 in the j direction, and plus 12 in the k direction. All right? And the way you find a dot product, it's very, very simple. You just multiply 0 times 0, which is 0, I times I. That would just be I to the second, and that, that's 1. So you end up with 0 here, 0 times 0, that's 0, and 2 times 12, that would be 24, and this vector k squared, you'll learn later that that's just 1. So you end up with the same 24 that we got using geometry. Much less efficient. This is much less efficient, but that's only because this was such a symmetrical shape, such a symmetrical prism. There are some prisms that would be more efficient to do it this way as opposed to this way. So this is mastery level. We encourage mastery level. I've got another problem. Let's look at this problem where we want to find the volume of something like this. All right, we want to find the volume of something like this. Let's attempt to solve this just using the technique that we just talked about using vectors. I drew a vector here. Okay, I used a vector here. Let's call this vector again the formula for volume. Let's take A dotted with the cross product of B times C. Same formula we used on the other side. All right, same formula we used on the other side. All right, so now what we can do is let's call this vector C right here. Let's call that vector C. Let's put it right here. Vector C. Let's call that, again, this is vector C. You're traveling 2 in the x. Again, this is my x-axis. This is my y-axis. And this is my z-axis. You travel, okay. So you travel 2 in the x direction. That's this vector right here. And you are traveling 0 in the y, and it's not going up or down at all. You're traveling 0 in the z direction. All right? Let's call this vector B. Let's call this vector B. And this vector here is going at somewhat of an angle. Hopefully, I tried to draw it as neat as I could. This vector here is traveling negative 2 in the x direction. It's going back, and it is traveling, it's not traveling in the y direction. Let's put a 0 there, and it's going 2 in the upwards in the z direction. So that's how we're going to identify vector B, and let's call this vector here vector A. The three vectors that are sort of forming this prism. All right. All right. And vector A, which is this vector here, that vector is traveling, it's not traveling in the x direction. It is traveling, it appears to be traveling 3 in the y direction. And it appears to be traveling 0 in the z direction. All right, so let's try to find the volume using this newer technique where we take the cross product of B and C. So let's do that again. The way we take a cross product, we establish I, J, and K. And B, we said that that was negative 2, 0, 2. That's my negative 2, 0, 2. That is my, negative 2, 0, and 2. Just checking my work. And then C, that vector is 2, 0, 0. All right, so let's find the cross product. Again, we focus on this I, and we eliminate these numbers in that column, eliminate those variables in that row, and you end up with I multiplied. You find the determinant of this submatrix. Hopefully you can see that that's 0. 0 minus 0, 0. Minus, by rule, J. And if you cross this column out, cross this top row out, hopefully you can see that the determinant of the submatrix will be 0. Sorry about that. 0, 0 minus 4. So that's a negative 4. And then plus by rule, K, you eliminate this column and this row. Hopefully you can see the determinant of the submatrix is 0. That's 0. So you end up with a 4J. Right? So that's the cross product of B times C. Now what we need to do is we need to find the product of A and the result of that. So the vector A was 0, 3, 0, 0, 3, 0. And I think I'll write this, I'll keep this here, but I'll just write this vector 0, 3, 0 in another way. Another way to write the vector 0, 3, 0 is 0i plus 3j plus 0k, all right, in the k direction. And we're dotting that, we're multiplying that by the cross product of B times C, so we end up with 0i plus 4j plus 0k. So we're finding the cross product. Finding the cross product is not very difficult at all. 0 times 0, that's 0. Plus 3 times 4, that's 12. Unit vector j times unit vector j, that's just 1. See, 12 times 1 is 12. And then 0 times 0 is 0. And you end up with a volume of 12. You end up with a volume of 12. We did that in pretty good time. Let's try to find a volume in a little bit different way. Let's maybe try to find the volume in a different way. The way you find the volume of a prism like this is, again, you take the area of the base, at capital B, area of the base times the height, all right? So this shape here is a parallelogram. And what I'd like you to, it's a little bit easier to see back here, the base of this parallelogram, that's 2, and I'd hope that you see the height of this parallelogram. Is real easy to see from this z-axis here. The height is 2. So the formula for the area of a parallelogram is base times that perpendicular height. The base is 2, the height is 2. So the area of the base is 4. The area of the base is 4. And then the height of the prism would be this perpendicular height here, the overall height of the prism, with this surface here being the base. If you see this surface here being the base, the height would be that perpendicular distance there, which would be 3, and you end up with a volume of 12. The same 12 that we got down here, mastery level. All right, mastery level. All right, so if you have a question on what we've done here, it's more linear algebra, or a combination of vectors and matrices. You call in the number 312-738-1060, or you can call in the number, the same number you see on the screen, and we'll talk about the problem that you have for homework. Maybe you're in summer school, you need help on your homework. You call this number, and I'll do the best I can to answer all of your questions. But if you don't call in, I am still prepared, because I've got more to talk about. I'm just so excited. But let's just jump into another problem where we're dealing with more matrices. Here's a different application, a different geometric application of where you can use matrices. All right, so this is a triangle. This is a little bit of a coordinate geometry exercise. And let's say you want to find the area of the triangle. You learn how to find the area in geometry. Area is just 1/2. Maybe I'll show the work over here. Area is just 1/2 the base times the height. Where the base here is this distance here, which is 7. So it's 1/2 of 7, top minus bottom, 4 minus a -3 is 7. Times the height of the triangle. This height is from here to here is 2. All right, so you get 1/2 of 14, which is 7. The area of this triangle is 7 units squared. All right, and that's probably the most efficient way to find the area of that triangle. Okay, but another way to find the area of the triangle is to take half the determinant of this larger 3x3 matrix. All right, so the first point, let's call that point 1. That's 0, 4, and then by rule put a 1 there. All right, now the second point, let's make this our second point. All right, so that's 2, -1, and then 1 by rule. And then let's make the third point 0, -3, and then 1 by rule. All right, so now let's find, we got half, let's find the determinant of this matrix right here in a little bit different way than we did on the previous problems. All right, so a way you can find the determinant here is rewrite these columns, 0, 2, 0, and then let's rewrite this column 4, -1, -3. And then let's just go through a series of mathematical operations. This product is 0. This product is 0 plus 0. And this product is -6. All right? And then what we're going to do is subtract some secondary diagonals. That product is 0. That product is 0. And then this product is 8. All right, 0 plus 0 plus 8. And what you end up with is half. And then you have -6 minus -6 minus 8. And you end up with half. Oh, I'm sorry. You end up with half times a -14, and you end up with a -7. But this particular technique accounts for, if you get a negative, you either take a positive or a negative, whatever you get. So you take the opposite of -7, which is the same 7 that we got before. So that's mastery level. You're doing the same problem in more than one way. We only have another 5 minutes in the show. So let's try to do this last problem using this technique, because If you try to use just basic geometry, it would be difficult. Not difficult. It would be somewhat. It was real easy to determine the base of this because it's a straight vertical length. But if you wanted to find a length of one of these points, you'd have to use the distance formula or something like that. So let's try to find the area of this triangle using this same formula that we have up here. All right, the same formula that we have up here. All right, so the area is plus or minus half, and now you find that the determinant of the first point, x1, y1, with a 1 by rule, x2, y2 with a 1 by rule, x3, y3, and then 1 by rule. All right, so I've already labeled the points for you. I'm very prepared today. You all very prepared today. All right, so we've got all 3 points here. We've got plus or minus half. All right, so the first point, let's call that the first point, 4, 2, and then 1 by rule. The second point, let's call that 2, negative 1, and then 1 by rule. And then let's call this third point 1, negative 5, and then 1 by rule. Up here, we found the determinant in a certain way. Let's find the determinant in another way. All right, so we have 4, and let's multiply that 4 by the submatrix here, the determinant of the submatrix. This product is negative 1 minus a negative 5. All right, negative 1 minus a negative 5. Minus by rule, let's take this 2, and let's find the the submatrix, when you use a 2, is 2 times 1, which is 2, minus 1. All right. That's, again, if you would have gotten rid of this column right here and this row up here, you'd end up with 2 times 1 minus 1 times 1. 2 minus 1. And then you have plus. If you use 1, you would have, if you use 1, you cross out that column, this row, you end up with a determinant of negative 10. Negative 10 minus a negative 1. Another way to say that is plus 1. Running a little bit short on space there. All right, so let's go through these calculations. And we should be able to get the area. So we end up with 4 times negative 1 minus negative 1 minus a negative 5 is 4. And then we end up with minus 2 times 2 minus 1 is 1, plus 1 times, this would be negative 9. So you end up with 16 minus 2 minus 9. You end up, oh, I'm so sorry. Sorry about that. So you end up with 14, oh man, rushing a little bit, 14 minus 9, and you end up with 5. You end up with 5. But this formula says take half of that, half of the determinant. So what you'd have to do is take, to find the area, you'd have to take half of the determinant that we just found of 5. You get 5 halves, or 2.5. Final answer. That's all we have time for. We only have a minute in the show. I'm teaching summer school at Providence St. Mel School, and I went to my students, I say, what do you want to do? What do you want to study? What do you want to grow up to become? One child said they want to become the President of the United States. Two children said they want to be computer technicians, computer engineers. Another young man said he wanted to be an entrepreneur. They were big dreams. Another young lady said she wanted to be an engineer. And if I can see my students doing that, how much, if you can see your students dominating, how hard are you going to prepare? How much time are you going to spend with them to make sure that they dominate the subject. See your students becoming the best, and I think it'll motivate you as a teacher. God bless you. Thank you for watching, and thank you for listening. That's all we have. Show's over. Have a good evening.